right. Okay, we're gonna get started. Um, as Kevin mentioned, x402 is a novel standard. It's early days, so once we get into this presentation, we'll understand that we're talking about how to make x402 a little bit better. So I'll be sharing today a novel enhancement to agentic payments. So first of all, who's at Genode and about us? We're the founding team behind the Graph protocol. It's the indexing and querying layer for blockchain data. We're the creators of the space, House of Web 3. Um, we're the creators of subgraphs, which is the core standards for querying blockchain data. We're currently building a product to redefine blockchain indexing once again, and that's coming very soon. Um, and the graph ecosystem introduced what we call TAP, which is Timeline Aggregation Protocol, which is a cryptographic solution for micropayments. So what I'll be talking about today is building upon the foundations of our learnings from what we've built there. And in the future, autonomous agents will pay for queries directly on the Graph network. We have some demos of that, and we'll be going further into that. And I'm, of course, Rodrigo Coelho, CEO of Node, and happy to be here. So why now? So as we all know, the rise of the agentic economy, it's a super hot space. We're all projecting in the future what this means. You know, we're moving from human interaction on commerce to trillions of dollars, and value will flow agent to agent and machine to machine. So we at Edge and Nodes, you know, like everybody else, saw this future, this tsunami coming towards us, and we basically said we've got to be part of this. We've got to surf this wave rather than being inundated by it. And so we've been laying the groundwork and working in stealth, and we're about to be sharing what we've done. So today is a little bit of the work we've been doing. Um, so again, we have a new product in the works to give developers visibility and control over their agents' payments. It'll be powered by the Graph infrastructure behind the scenes, as we're experts in providing that data. And it's backed by years of protocol level innovation. So we're uniquely positioned to deliver what the industry needs next. Next slide. So I'm going to get into our contribution to X402 now. Um, and we call it the deferred payment scheme. So X402 currently supports a tenth of a cent and 0.2 second settlements. So if we project into a future where there's millions of agents interacting millions of times a second, ultra-fast payments are going to be needed, and so settlement per transaction doesn't make sense. And as Kevin showed, and I'll show real briefly, in the X402 standard currently, there's a settlement per transaction, and so as you scale, you know, to millions of times per second, there may be instances where that doesn't necessarily make sense. So enter the deferred payment scheme. So I'll just do this really quick since Kevin covered this, but currently in the exact scheme, the client, it requests a resource, the server responds, client retries with the payment header, and then there's a verification and a settlement that happens, right? So the on-chain transaction costs and gas fees limit of how low of a payment you can accept before it doesn't make financial sense, right? If you're going to be doing a micropayment less than a tenth of a cent, you know, a millionth of a cent, for example, then paying the gas fee for that settlement doesn't make sense, right? So it's a natural extension to think, okay, how do we scale this? And in the Graph protocol, for example, we're dealing with billions of queries, and these queries are, you know, less than a tenth of a cent. And so it was a natural conclusion for us to say, okay, in the future, it's not just humans interacting, it's going to be agents that are going to be hitting the Graph protocol. And so we need to be able to handle this situation. We had actually already built that in what I mentioned earlier in TAP. And so we said, okay, how can we implement this and bring this to the x402 standard? And so enter the deferred scheme. So it's very similar to what we saw before. The first part is the same. You have the client requesting to the server. In the first step, there's a previous history with the client. So what we call a voucher, and I'll get to that in a minute. The client retries with the X payment header, verifies, and then it does the work to fulfill the request. And as you see, there's no settlement yet. And then eventually the server decides to settle the pending vouchers. And vouchers are like IOUs or receipts. You aggregate them up and then you settle periodically. And that can be set. It could be a day, it could be a week. It can be set programmatically. So you just batch up all these IOUs and then settle them as needed. And so then you aggregate all these microtransactions to a level at which when you do eventually settle and pay that gas fee, it makes economic sense to do so. So this is the technical kind of details of how the header looks like in the scheme, and using signed IOUs as payment commitments. So clients, we say the word pay servers with vouchers. Vouchers are aggregated, settled in a deferred way at the server's convenience. And so the single gas fee is bundled against a number of transactions. So here's a link to access the PR in the x402 repo in the GitHub. So that is currently being reviewed. I spoke with Eric last night, who's the author of x402. It's on his list to review that PR, but we're expecting after some public comment and feedback that it will be incorporated into the standard. And so, yeah, we're expecting that very soon. And I'm going to bring up Kevin now to do a quick demo of what we've got working, and then I will close it out.
All right. That's really loud. All right, cool. All right, so for this demo, we're going to be spinning up some different services. I'll try to kind of explain those because it is somewhat of a complex demo. First, we're going to spin up a facilitator. It's a custom facilitator because it does need to work with this mechanism of like vouchers. And so this is going to be running essentially as an endpoint to act as our custom facilitator with x402. Then we're going to spin up a custom MCP server. So this is actually an MCP server that is sitting in front of subgraph MCP. So if you're not familiar with the graph has GraphQL API endpoints that let you get access to various on-chain data from smart contracts. And so all this is an MCP server sitting in front of that subgraph MCP server. Well, it's a custom implementation of that with x402 enabled. So essentially no API keys necessarily. That's all handled using x402. And then we have a proxy. And so this MCP proxy is basically running so that if you have like something like Claude or some kind of source that's hooking to an MCP server that doesn't have the ability to understand how to interact with x402, this basically is acting as a proxy to that. And then the very last thing that we're spinning up here is the Google ADK. So it's a web server essentially running in Python that is a Google agent framework that allows you to kind of build agents. And so we're going to start that up, and that's going to run on, I think, port 8,000. Yeah, 8,000. So a lot of services going, but that's kind of like what you need with this kind of setup. It's somewhat of a complex setup. And we can go here and take a look at the UI. So if anyone's ever used Agent Development Kit with Google, essentially you have these like agents that you can create. And so in this case, we have this example agent, which is a deferred agent that is configured to point directly at the subgraph MCP via the proxy. And we can ask questions. So let me increase the brightness here. So we'll say like, please give me the 3 most recent ENS names registered? Sure. So what this is going to do, it's going to determine how to query the subgraph MCP by calling various tools. We can look at those event calls that are being made here. So you can see right now it's trying to find the proper subgraph to utilize, and then it's also trying to figure out exactly what kind of schema that the subgraph has and how to get access to the data. And then it's actually going to make a query and hopefully come back with that data. So it looks like it finally was able to determine the query and then make this. But these are all requests, and there we go. We got our result. And so we have the last 3 ENS names that were registered. And so if we come over here and we look at the output, what we're working with is, again, the subgraph MCP server that's x402 enabled. And so all of those responses are actually coming back without any on-chain activity. So we're using this voucher system. So if you come over here, you can see the most recent voucher. Let me make this a little bigger so you guys can see. So here is one of the payment events, and we can see here that it's on base Sepolia. We can see that it's using the deferred scheme. And then we can see that there's an ID associated with it, a buyer and a seller, which are just public addresses on Ethereum. There's a value aggregate, which is the total amount that buyer has requested using the deferred scheme. And then there's the asset of where the cost is to pay, essentially. So that's USDC on base Sepolia. And then there's this nonce, right? So the nonce is like keeping track of all the requests that the user or the agent is making, and then kind of like correlating those. And then things like the chain ID, the expiration date, the timestamp, and then you'll see at the very bottom is the signature. So the voucher is basically included in the request from the agent, and it's signed, right, to prove that that person has access to that private key to require that, right? So if we come back over here and ask another question like, what are the most recent swaps on Uniswap? Enter again, we'll see this start to aggregate more, right? This is currently value aggregate 640. It should, there it goes. 660. And we're seeing these new vouchers being created. So anytime that it needs to go out and request some data from the subgraph MCP, it's creating a new voucher, increasing the amount that the aggregate is required, and then it's basically, there it goes, so 660, now it's at 680. So these are like kind of tallying up all the payments, and none of this at this point is on chain. So if we look at the Block Explorer, and we look, the last transaction on the facilitator address was about an hour ago when I was testing to make sure it was all working. And if we look at the actual escrow contract as well here, we can see again that the last thing was about an hour ago. The escrow contract is actually what is holding the asset that the agent has the ability to spend. And so with this private key, we've gone ahead and said, hey, let's deposit some USDC into the escrow contract, and then so that there's a spending limit. And we can look at that right here at the bottom and see here we deposited 0.05 ETH into the contract. Actually, I'm sorry, it's down here. It was like 0.1 ETH or something like that. The internet's acting up. Okay, there we go. Yeah, sorry, it's 0.1. No, it's this one. So go to token transfers because it's USDC. Okay, the internet is not doing well right now. Okay, well, we're going to try to settle it. So I want to show you that at least you can see here that there is no settlement that's happened in the last hour. So now what we're going to do is try to settle all of our vouchers. So right now we have a value aggregate of 700. So what we need to do that is just make one simple API call to the facilitator and pass in the proper ID and the nonce. So we're going to grab the ID from the most recent voucher here, paste it in, and then we're going to put in the nonce because we need to say like what the nonce of the signature is, and we're going to settle it. So that's one curl. This is now going to execute the entire list of vouchers that are owed. Is pending my internet. I might have to connect to my cell phone if it doesn't work. Actually, it should work because it's just local, but Okay, there it goes. All right. So now if we come over here and refresh, we can see, first of all, that the facilitator address has issued basically a settlement. So there's a slash settle, right, that we called 11 seconds ago. The facilitator paid this much in gas to basically execute the transaction. And here we can see that the amount deducted from the actual facilitator is on this tab. Sorry, it's running really slow. It's the demo gods. Okay, there we go. All right, so if we go to token transfers, we can see here that there was a bulk USDC payment. If it loads, come on, we can do this. Connect to my phone real quick. Let's try it one more time. Okay, there we go. Token transfers. So there we go. 1 minute ago, there was 0.000018 USDC cent in a finalized transaction. So yeah, so that's pretty it. So yeah, we were able to essentially make a bunch of requests, not do those off-chain using the aggregation of the vouchers, and then settle those in one final settlement with the deferred scheme. So, okay, cool. Now we'll bring back up Rodrigo.
All right, thank you, Kevin. So again, early days, so this is human interaction, super slow, but imagine scale this up. You've got machines doing this, and this is happening at high velocity. And this is to give you an idea of how it works at a base level. So coming soon, a product to help agent developers. I'm not announcing it today, but it is coming soon. So many of the things discussed today will be relevant. So in terms of like auditability, visibility, spending limits, et cetera, controls over your agents. We're building a tool to help with all of that. That's integrated with x402, Google A2A. So we will be announcing that soon. Um, and so we're looking for design partners, people that are building agents. Come talk to me or Kevin, and we'd like to see what you're doing and see how we can work together potentially, how this tool might be able to help you. Um, so subscribe for updates. Here's our X account and our LinkedIn, and thank you all for your time. Right. So we're done a little early. We can take questions, and if not, we'll set up for the panel that comes next, and we can ask more questions there. Slide back. Yes, there you go. Question, yes. In the deferred scheme, yes. So you're actually depositing funds into the escrow account. So you're actually proving that you have the funds there as part of it. So essentially, the seller can't get rugged. Yeah. Yes. Yeah. So effectively, there's an escrow contract, and so the funds are there held, and that's what the seller deducts from when you do the settlement transaction. So actually, you are locking up funds there while you're doing your IOUs and vouchers. The funds are sitting there in a separate smart contract that's under your control. Yeah, yeah, super vast. Yeah. What's DSP? Okay. A what? Demand side platform. Okay. Learned something new today.
like you buy one on Target or one from Amazon, how would you handle competing for the same request?
Um, I'm not sure what you're asking. Yeah. Yep. Yep.
So more and like one, one,
Right.
um, turning multiple.
Yeah. So your question deals with more like what the agent is doing, right? So you've got an agent that says, find me a green dress, right? That's your agent. And then the agent is going to go out and find other agents that can like fulfill that request for them. And so that part is what you're asking. Is like, how are the swarm of agents, like, how is my agent going to interact with the swarm of agents saying, I can fulfill that request for you? It's going to pick one agent, right? And then that one agent is going to go and find the best green dress, but you're not in control of that interaction. Like we're dealing with like agents acting autonomously, right? And so like with the deferred scheme, like that you're basically on the agent side is how that payment is fulfilled. Like in a case of a green dress, like it may make sense to just use the exact scheme and settle it, right? Like the deferred use case is more for like high volume, high throughput. Like the exact scheme as it exists would fill many, obvious use cases because it goes down to a tenth of a cent, like the gas fees are nominal. So yeah, this is really meant for like machine interactions that are working at super scale, like web scale stuff. Yeah. Okay. Yeah, we can talk more about the panel. Okay. Yeah. Yeah, so the initial part where you interact with the server slash facilitator is off chain. So that happens where you make the request and the voucher communication happens off chain. And so between the client and the server, you're aggregating these IOUs. And then when you hit the settlement part, so the server issues the settlement, that is what happens on chain. So the payment then when it's the final payment is made, that gets registered as a on-chain transaction. Yeah. Yep. Yeah, so we didn't show that part of being on chain, but that part is, yeah. Yeah, if we want, we can during the panel we can go deeper into that. Yes. It's it's each client, right?
Yeah, essentially each buyer, right, needs to have an S. So like you can think of it in this case, like we have one smart contract deployed. So the facilitator would point at that smart contract, and then the buyer would be, the person who's staking the USDC. Yeah.
Right. So as a buyer, yeah, if you're interacting with many, um, your oh yeah, so your sort of escrow, you could use that address to interact with many different agents. Yeah, so that's actually kind of what we're working on. Yeah.